All right, everybody. Welcome back. Hope you had a good spring break. Time to get back down to business, though. Do you all remember at all what we were doing before spring break? We covered the product and quotient rules for taking derivatives, right? And so today is going to be a lot of me giving you problems to do, okay? Because I can show you all day long how to do this, but you have to be able to do it, and you'll be able to identify where your weaknesses are here. So because today we're going to cover chain rule, and it's a very simple rule. I'm just going to give you, it's almost like a formula, not exactly, but it's almost like just a formula. And then from there, I just start throwing problems at you, and you just kind of see how you do with them. All right. So it'll be like me give you an example, and then you go try one. Me do an example, you go try one. All right. Sound good?
So I have a quick question.
Yep.
When I was on the book that we studied from, it said that we had an online Zoom exam due by Friday.
When you were doing what?
When I was entering the website for the book that we studied from, it said that we had an exam due Friday.
Oh yeah, no, just ignore that. That's not, that's from my online calculus class. I have an online Cal 1 class that's taking an exam Friday.
I feel so much better. Thank you.
Yep. Okay, any other questions? All right, here we go. All right, so to the notes. March. All right, so we're going to start with some warm-up problems. So these are problems that you should be able to do right now at this point. Now, you might need your formula sheets. You might need to refer to your notes, but I'd like for everyone to work these three problems out. I'm going to put up a poll, and when you have completed the first, well, you know what? If you complete all three and you get answers for all three, then go ahead and on the poll just say yes. Okay. So here comes the poll, and if you're on your phone or something, you can't do the poll, that's okay. Just want to see how long it takes most of the class. I'll zoom in on this so you can see a little better. All right, so we want the derivatives of all three of those. All right, so have at it. And then what I'll do is after we get enough people that are done, I'm going to call on people just randomly. I put a little timer there. You can see how much you can get done in about 6 minutes. We'll just see where everyone is in 6 minutes. Got 2 minutes left. We have 6 people that say they're done. Okay, that was 6 minutes. So, so on a test, all right. Now I realize everyone's coming back from spring break. We only had 7 people say they finished, but on a test, I would more than expect that you could finish those 3 problems in 6 minutes. All right. So just so you understand the expectation, part of what makes the next test harder is that it's not about can you do it, but it's can you do it within a certain time frame. So it's about efficiency at the same time as knowing what to do. So let's work through these. Gene Alvarez, you're the first up here. Gene, you there?
Yes.
Okay, you ready? What do you do on the first one? You feel okay with it?
I honestly struggled with the first one. I remembered how to do the quotients and the products really well, though.
Or you want to do one of those then?
I could try.
Okay. You want to do 2? What'd you do for 2? Tell me what you did.
For 2, I started off by bringing down the 3.
Okay. So you applied which rule to this?
It was I'm looking at my notes. I can't find it.
Well, you said you did better with the product and the quotient, right?
Mm.
So this number 2 is a product, right? You have multiplication between these 2 functions.
Yeah.
Right. So we could call this one like F and this one's like G.
Mhm.
And then you applied the formula F prime times G plus G prime times F, right? That's what we're going to do.
Yes, the product.
Okay. Product rule. Okay. So what'd you get? You said you brought the 3 down, 3, and then X what?
X squared.
Squared. And then you wrote what?
And then I wrote G just as is, so cosine X.
Times cosine X, and then plus.
And then this one I kind of struggled with, actually.
So you need the derivative of cosine, right?
Yes.
So the derivative of cosine, somebody else?
Is a negative sign.
It is
X?
negative sine of X.
Mhm.
And
And then just F as is.
F, which is just X cubed. There we go. Now I'll just clean it up a little bit. I'm gonna, because I have a plus and then a minus on the sign, I'm gonna bring the minus, I'm just making a minus, and I'm gonna bring the X cubed out in front of the sine X. Does someone remember why I said I like to bring the X cubed out in front and not leave it out here in the back?
So that way you don't get confused.
Yeah, that way you don't think that this X multiplies with that X cubed, right? You don't want to make, you want to make sure that you understand that that x is trapped inside the sine function, right? This x cubed cannot join it in there. All right, that's it. That's the derivative. Okay, good. Austin, you're up next.
Okay. Which one?
Which one do you want? One, two, or one or three?
I'll do one.
Do one? Okay, so how'd you do number one? What was
Uh,
your thinking through this?
oh, I just applied the power rule.
The power rule.
Yeah.
Okay, and you did that for each one of these separately?
Yes,
Why are you allowed to do them separately?
because it's not multiplication or division.
That's right, because there's not multiplication or division. If you have addition or subtraction, you can just do them individually. So you just take derivative of the first one. What'd you get there?
It's going to be 3 times 2x. To
3
the
times 2x. And then how did you deal with this? Because it was a fraction. How did you deal with that?
I just looked at it as, I mean, I just like took the x squared and did the derivative of that
Okay.
on the bottom.
What did you do with the one on top?
Nothing.
Yeah. Okay, so good. This is a good lesson for everybody here. So if you're not gonna, if you want to treat this like a quotient, then you have to use the quotient rule. Like if you want to do 1 divided by x squared, then you're going to have to do quotient rule there. But your other option is to realize you could rewrite that as x to the -2, right? That's what 1 over x squared really means. And if you rewrite this as x to the -2, then you can just use the power rule, right? Which would mean, Austin, you bring out what in front?
The -2.
-2, and then it would be x to the what? Be careful there.
-3rd.
-3, because you have to subtract 1 from -2. Are there any questions on that? I'm going to clean it up a little bit. This is gonna be
Real quick,
6x. Go ahead.
I did that one a bit differently, but I believe it's still like the same value. I
Okay.
got 2 over x cubed when
Yeah.
I factored that. I just used a reference from the homework I did.
Okay, so you got the derivative of this to be this, right?
Yes.
Okay. Now, are you saying you did it different than looking at it as x to the -2?
Yeah, I did it differently.
Did you do the quotient rule?
The quotient. Where I took derivative separately.
Yes.
Yeah, I
Well,
did that.
so look, I want everyone to pay attention to this because this is important. Look, if we have 1 over x squared, you can do what I did here by bringing the x up and making it x to the -2 and then do the power rule, right? Bring the power down, subtract 1 from the power. That's the easiest way to do it. But if you're insistent upon keeping it as a quotient, then you have to treat the top like f and the bottom like g, and then you have to use the quotient rule. And if you do that, let's just walk through it. What would the derivative of f be?
0.
0, because 1 is a constant, right? So the derivative of 1 is 0 times g, the bottom is g, that's x squared, minus, now the derivative of g, what's derivative of g?
2x.
2x, and then times f, and f is just 1. I apologize if y'all can hear my dog. I have someone in the house and the dog is not happy. Okay, and then g squared would be x squared squared, which would be x to the 4th. Now, so far, this does not look like our answer, but let's just clean it up. 0 times x squared is gone, and that just gives me -2x on top over x to the 4th. And since I have 1x here and 4x is here, I can cancel an x. And that leaves me with -2 over x cubed. Right?
Yes.
Hold on a second. I think there's an error in this answer right here. Hold on, I did something wrong. Do y'all see this stuff? Do y'all see this? Do you see
Yeah.
how we got to the same result as we did right here? Do y'all see that that's the same result as that? But do you see the quotient rule was like, we just took a lot of time to do that, where it should have just been bring the -2 and then drop it out front and subtract 1, much easier. Y'all agree? Do y'all see what I'm missing?
Isn't it supposed to be positive?
Yeah, see, this was a minus sign, right? So that was already a minus sign. And then I was supposed to bring down the -2. So that should be a -2 there. Yes or no? I'll erase this. And if I replace this with x to the -2, then when you bring this -2 out, it's going to turn that into a plus. So this should be a plus. And I just overlooked that, sorry. Okay. The third one. Gage, are you with us? No Gage, no Gage. Okay. Cody?
I'm here, although I need to redo it because I did the second one wrong. So I obviously got this one
Okay, so
wrong.
what did you do wrong? I think it's useful for us to learn from our mistakes and other people's mistakes. So what were you doing that was wrong?
I didn't get I forgot that the x was tied to the tangent. So I didn't do the derivative of the tangent.
So what do you mean by that? You said the x is tied to the tangent, so it's actually inside the tangent like this.
Yes. But what I did was just I did x0, so I just did tangent of 1 instead of like actual derivative.
Okay. So what rule would we use here, Cody? We have the power rule, which is the rule we used up here. We have the product rule, and then we have a quotient rule. So which rule would apply here?
The quotient rule.
Quotient, right? The entire numerator is going to be our f, and the entire denominator is going to be our g. And so we need to do f prime g minus g prime f all over g squared, right?
Yeah.
Okay, so let's just take this one step at a time. The derivative of this function should be, all right, take derivative. What's the derivative of the top? Can you do these separately?
Yes.
Yes, okay, because there's their addition. Derivative of tangent x?
That's forgot.
Okay, so that one, derivative of sine, cosine, and tangent, everyone try to memorize those as soon as possible, okay? Derivative of tangent x is secant squared x, right? So we're gonna do that, and then we have to do plus the derivative of 1, but the derivative of 1 is 0. So we should only get here secant squared x. That's f prime, right? Now, Cody, what do I need to put next to that?
Minus 2x.
Okay, so you're right here. You're doing this part right
Oh,
here.
sorry, plus 1 first.
No. This, all we've done so far is we took the derivative of f, right? We took derivative of that top piece, which was this, right? We still have to multiply it times g. What's g?
Oh, x squared plus 1.
X squared plus 1. So I need that in parentheses because it's 2 terms and it's being multiplied times this. That means I need it in parentheses. Now you can do the minus. And Cody, what's the derivative of the bottom?
2 squared. I mean 2x plus 1.
Yes. Okay, we're good. All right, thank you. 2x, good. And then we do what? That's just this part, right? What do we still need next to that?
We need the top next to it.
The top, right? And since it's 2 terms, we're going to put in parentheses. And then finally, all of that over the g, the bottom, right, squared. All right, and that's it. That's our derivative. Any questions on that? Anyone?
We don't have to go any further than that, right? We don't have to like put it together. in any
Yeah,
way?
so what we have right here is what you're going to hear me refer to as the raw derivative, okay? That's not a mathematical term, okay? You won't see that in a textbook. I call it the raw derivative. It is the derivative It's what the derivative looks like as soon as you apply the rule. Now, could you do some algebra to try and clean that up? Yes, we could, but that will come later. We're going to be doing something with this answer later on. For right now, I just want to make sure you can get the raw derivative. When we do the algebra later, we'll do it. All right. Okay, good.
I have a quick.
Now, I will warn you that if you're trying to take derivatives and you're doing your homework and you look in the back of the book, your answer may look different than their answer because they may have simplified things. So just be aware of that. Okay.
I have a quick question.
Yes, what's up?
So then if we were gonna do this, is that, that wouldn't, the secant squared x times the x squared plus 1, that's not something that is within, basically like chain rule, that's not something that would be considered like within it, right? It would just be like, I don't know how to explain it.
The x squared plus 1 is not inside of the secant. Is that what
Okay.
you're asking?
Yes.
Yeah, that's right. It is multiplied times the secant of x.
Oh, okay. So then I could do
Yeah.
like the product rule and da 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 da.
If
right?
you were going to take the derivative again, yes, you would have to treat that like a product.
Okay, just wanted to be sure.
Yep. Yep. Okay, so look, I mean, everyone in this class is going to be at a different level right now in terms of where they are comfort level with these derivatives, but I'm trusting that you've done your homework, that you understand your homework, that you've done everything up through and including the quotient rule. Okay. So now we move on to the chain rule, but I have to warn you that if you're not comfortable with these rules, chain rule is going to be a nightmare. Okay. So you have to get comfortable with these rules or else moving forward will be very, very challenging. All right. So practice, 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 practice. Go do the homework. Do the other problems that I didn't even assign. Just keep trying. Go on Google or something and say, you know, product rule, sample problems, calculus, and just, you know, find a worksheet or something. Keep just drill, drill, drill until you feel comfortable. All right, so we ready for chain rule? Here it is.
Yeah. Woo!
All right, thank you, Danielle. So the chain rule. This is the most important rule when it comes to differentiation, right? It's the most important one. Mastery of this rule will drastically improve your chances of success in this class and future calculus courses. So if you can't get chain rule down, your road on calculus is going to come to an abrupt end. Now, it's a little weird, okay? But just like everything else, we just have to practice, practice until it starts to click, all right? Here's the rule right here. This is it. It's very simple. It's very simple to state the rule. It's just a few letters and symbols. That's it. But it's hard to make sense out of what it's saying we do. All right. So I think what we'll do is we'll start with an example and then I will come back to the formula in a second. So let's take a look at this example right here. Let's say that we're given a function. I'm going to call it y equals sine of x squared. Now, what I want you to notice about this is that the x squared lives inside of the sine, right? This is not sin times x squared, right? That would make no sense. Like what's sin, right? Sin is nothing. It's sine of x squared. That's the way you'd say that. Sine of x squared. So we don't have multiplication here. What we have is what's referred to as composition. This is a function that is inside of another function. Do y'all see that? The x squared function is inside of the sine function. One way you can verify that this is composition is to think about what would happen if you plugged a number in for x. So let's just say, for example, we plugged in, I don't know, 2 for x, right? If we let x be 2, then what would happen? We would first square the 2, wouldn't we? We do 2 squared, and that would give us 4. So we would have sine of 4. And then we'd have to figure out what sine of 4 was, and we'd probably just break out our calculators to figure out what sine of 4 was, right? So there were like 2 steps you had to do. You had to plug in the 2 and square it. That was the first thing. You squared it. And then after that, you did the sign. So if you look at that as like layers of an onion, you had an inner layer and then an outer layer. The inner layer of this was the x squared, and the outer layer was the sign. Is that clear to everybody?
Yes.
Yes? Okay, so the question becomes, how do you take the derivative of something like this? Right? It's not the power rule because it's not x squared by itself, right? It's not x squared by itself, so it's not power rule. It's not product rule because we already said it's not this. And it's not quotient because, well, there's not a fraction, right? So we don't have at this point any way of taking the derivative of this. And that's where the chain rule comes into play. So the way the chain rule works is this. I'm going to write the chain rule down here. It says if you have y equals some function f, and inside of that function, you have some other function g. So I want to point out that this is the outer function, and this is the inner function. That if you want the derivative, then what you're going to do is this. So here's the chain rule right here. It says you're going to take the derivative of the outer function, and inside of that, you are going to put the inner function with no derivative on it. And then you will multiply. This is where the word chain comes into play, because now we're creating a chain of multiplications. You're going to multiply that by the derivative of the inside function. All right, so let's see if we can't follow that logic in this problem. So what is the derivative of this? Okay, so I'm going to call on someone here. Fiona, are you there? Fiona's not here. Emmanuel?
Hello.
Hi, Emmanuel. How's it going?
It's going good.
Okay, so Emmanuel, what I want to know here is which of these two functions is the outer function?
That would be sine.
Sine. Okay, so according to this formula, it says if we have an outer function, right, and an inner function, the derivative of this, what we do is we start by taking the derivative of the outer function. So Emmanuel, what's the derivative of the outer function? So what's the derivative of sine of something?
That would be cosine of x.
Cosine, right? It'd be cosine. You said cosine x, right? Isn't that what you said?
Yeah.
However, look at the formula. It says you take the derivative of the outer function, and inside of it, you do not plug x in. What do you plug in?
G of x, or
G of x, which is the inner function, right? So what was the inner function here?
x squared.
So we're going to do cosine of x squared, not cosine of x. Does that make sense, Emmanuel?
Yes.
Okay. And then the rule says you then multiply that by what?
The inner function.
The inner function's
Derivative.
derivative. Now you can take the derivative of the inside. What is it? What's the derivative of the
2x.
inside? 2x. And we cannot put these x's together because this x squared is inside the cosine and this one is not. So our answer here is 2x. I'll bring it up front, cosine of x squared. So to reiterate, this right here is kind of like our outer function's derivative with the inner function in it times, and then this piece right here is the derivative of the inner function.
That's it.
That's it.
You had me scared for a moment.
Okay,
It's gonna
well,
get wild. It's gonna
hang
get wild.
tight, hang tight. Okay, we're just beginning here. But this is truly one of those things where it's kind of a light bulb. So when the light bulb does go off and it all makes sense, it does become much easier. But if that light bulb doesn't go off, it becomes like an impossible challenge. Okay, so here we go. We're gonna do another one, all right? And we're starting off with easy ones. So this time, what I want to do is cosine I'm just gonna write it down. I don't want to say anything. I just want to write it down. All right. Matthew, you there?
Yes, I'm here.
Matthew,
Yes.
do you see power rule? Like x to a power by itself without anything else?
No.
Okay, do you see product?
I don't think so.
Good. There is no product here. And everyone needs to be aware that we are not saying here cosine times sine. That's not what this means.
Cosine in the, or sine in the cosine? Like
Yeah, this sine function is inside the cosine function, isn't it?
Mhm.
So you have composition here, Matthew. And if
Yeah.
you have composition, you must use the chain rule, which means you have to identify which of these functions is your inner function and which one is your outer.
Yeah.
Okay, so you tell me which one's the outer one and which one's the inner one.
Cosine is going to be the outer one and sine is going to be the inner one.
Okay. All right. So according to the chain rule, you're supposed to start by taking the derivative of the out, right?
Yes.
Inside of it, you plug in the inner with no derivative, right? No derivative on that. So Matthew, what is the derivative of the outside function?
Negative sine.
Negative sine. I like the way you said that, negative sine. And what am I going to plug in? I'm not going to say negative sine of x, right?
No.
I'm going to say negative sine of what?
Sine x.
Of sine of x, because the inner function is sine of x. Does everyone see that? This is the derivative of the outer function, which is negative sine, but inside of it, you're plugging in the inner function with no derivative on it. Are we done, Matthew?
No, because you still have to multiply by the
What are we
derivative.
multiplying by?
The inner.
The
So,
inner. And the
uh,
inner function, well, the inner function's what, derivative?
Yeah, the derivative.
This is the inner, but this time it's the derivative of the inner, which is what?
Cosine
Cosine of
x.
x. Good. So again, this right here is like the f prime of g of x, and then times, this is the g prime of x. What do you think? Still okay?
So far.
So far, so
Okay.
good.
Good. Your turn. I give you one now. All right, let me give you 2 minutes.
So we're just gonna, that like, once we just, we're leaving it like that, right? We're not gonna keep
We're
going,
just solving this one, I guess.
you know what I mean? Cause like, if we're just leaving it, then I'm done, you know what I mean? Like, I don't know.
Right. Just take a derivative and we're done. That's what he
Yeah.
said. so far.
Oh, okay, I didn't know if we're gonna continue, go forward and go forward.
Not yet,
Yeah.
later on.
Yeah, just take the derivative.
Okay.
Can I go this time, Professor, if you don't mind?
You want to volunteer? Yeah, that's fine. Are we
Um,
ready? I think we're ready. Let's do it. So
It
feel
was
free. I'm just going to ask you just for the answer first. Okay.
Oh.
You just tell me what to write.
it's secant square in parentheses x to the cube plus 2x plus 1, and then multiply 3x squared plus 2.
Have I written that the way you want me to write it?
Yeah.
Yes.
hmm
Okay, so what do y'all think? This is pretty good,
I got the same thing.
you know?
Yep.
Okay, it's not completely correct.
If-
Something
Parentheses.
Could
wrong.
we move the last portion to the front to make us, like how we do earlier, to not make us confused? or
We
do-
can move the last portion to the front, but there's something missing the way I wrote it. The way I wrote it is not technically correct. Because look at the formula says it's this thing, right? F prime with G inside that, Dilpreet, you got that perfect. It's perfect. But then you're supposed to multiply times G prime, right? So you're multiplying times G prime. Problem is G prime has two terms. And so if you were to multiply these together, the way we've written it right now, the only two things multiplied together are these two things, right? You need it to be all of this. So what you have to have here is parentheses around those two terms. It has to be there. Does
Got
that
it.
make sense to everyone?
Yeah, the notation is.
Yeah, it's not an option. I mean, think about it this way. If I asked you to do 4 plus 3 times 2 plus 7, think about order of operations here. You're going to do this first, right? And get 6. And then you'll do all your addition. That's very different than me doing that. Now you're going to do 2 plus 7 first. That's 9. And then hit it with the 3. That's going to give you a completely different answer. So if you don't have these parentheses here, then all you're doing is multiplying those two together, and that 2 is being added at the end, which is not what is supposed to happen. It's supposed to be all of that on the left times all of this on the right. I hope that makes sense.
Yes.
Okay. All right, let's do another one. Give you 30 seconds.
This 30 seconds feels like a long time.
I know it does. Okay, so how about this? Brian, is Brian around? This was not a trick question. Brian, you got
Yeah.
it? You want to just tell me
Oh.
what the answer is?
No, you got me off guard when you said 30 seconds. I don't have it. I'm sorry.
But I think you can do it. Do we have an inner and outer function here?
Yes.
What's the
Right.
outer function?
Outer and inner is the 4x.
Okay, so start with the outer. What's the derivative of the outer function?
It would be cosine,
What goes inside of it?
the 4x.
Okay, and then times?
Times it would be the derivative of the inner, so it would be just 4.
4. Okay, good.
Do we have to
So
put that
I'll
in
move that
parentheses?
4 up front. Excuse me?
Do we have to put that in parentheses? Because it's just like
The 4 doesn't have to be in parentheses. Or are you saying the 4x?
no, I was meaning the 4.
No, because it's one term. The reason we had to do it here is because we had 2 terms. That's why we had to have parentheses here. But if it's just 4, then yeah, you can just slide the 4 out front. Okay, so look, if we have a number in front of x like this, we have to be a little careful when we take the derivative, because whatever number's in front here should pop out, shouldn't it? Like another example, if I said something like y equals, let's say, sine of, I don't know, pi x. If we take derivative of this, it's going to be cosine of pi x times pi, because pi is a constant, isn't it? Just like the number 4 was a constant. And so when you take derivative of pi x, you just get pi. Is that clear?
Yep.
Yes.
Okay. So how about this one? I'm not going to do this example.
Hey,
I'm going to call
professor.
on somebody. Excuse me?
I was just wondering, I mean, I know it's just a stupid question, but what if we accidentally put a cosine x and then in parentheses 4x? Like what it's gonna do? Like, is it gonna mess up whole problem?
Oh yeah, that'd be all wrong. Yeah, you're saying instead of this right here, you did like cosine of 4?
No, no, no. Like cosine x and then parentheses 4x.
Yeah, that would be wrong.
Okay, just want to make sure. Thank you.
Yeah, the important thing about the chain rule is that when you take the derivative of that outer function, what goes in it must be the inner function. It can't be x, it has to be the inner function.
Got it.
Right.
Thank you.
You know what, before we do this, I want you to think about this. And when we're sitting, well, what's going on? Whoa. When we are looking at, let's say, sine of x, right? I ask everyone right now, what's the derivative of sine of x? And everyone's like, cosine of x, right? Everyone's happy, right? That's derivative of sine of x. I want you to actually see that we've been doing chain rule, but you didn't even realize it. Because there is an inner function and an outer function here. The outer one is sine and the inner one is x. So let's do the chain rule here. What is derivative of sine of something? Well, cosine of it, right? And what goes inside? The inner function, right? Which is just x. And then chain rule says now you multiply it times the derivative of what's inside. But what's the derivative of x?
1.
1, right? Which is just cosine of x. So you didn't actually understand that when we were doing it, but we have been doing the chain rule. It's just now we are actually like having it be more complicated. What's inside here is now more complicated than x, right? Like this, it's 4x, or here it's tangent of all this stuff, right? Okay, Elise, you're up. Are you here? Are you here?
Yeah, sorry.
Okay, no problem. Okay, so Elise, I gave you kind of a harder one that we haven't really talked about. So maybe you can tell me what you're thinking.
Do you want me to give the full answer or walk you through it?
Do you want to just give me this full answer?
Sure.
Okay, go ahead.
3x squared times sine of 10x, and then plus x to the third times 10 cosine of 10x. All in parentheses, that 10 cosine 10x.
You want all of that in parentheses like that?
Oh no, including the 10.
Or
Well, I
you
guess
want
it
the
doesn't
10
matter
now?
since it's all multiplication.
Yeah, it's all multiplication, so you don't need it. Okay, what kind of voodoo weird shit did you just do, Elise? I have no idea what's going on. Do y'all know what's going on here? This looks crazy. It's correct. It's
You
correct.
have to do
But what are you
the
doing,
product rule.
Elise?
Yeah, it's
What's that? Everyone see what she's done?
Mm-hmm.
I have a question about this.
Yeah.
For the 10, do you have to move it to the second one, or can you leave it out?
You could leave it out. You could leave it out. There's different ways we could write this. So Elise, when you looked at this, what did you see?
Product rule.
Okay, everybody, we have to see the product rule. We have to see that there's multiplication here, right? There's x cubed times sine of 10x. And because it's product rule, that means you have to call one of these like f and one of these like g, and then follow through with the product rule, right? Product rule says, that we should have f prime times g plus g prime times f, right? So that's all we need to do is figure out what that is. Now, the way Elise did it is she said, okay, f prime, right? So she took the derivative of x cubed, which was just 3x squared, and then times g, which is just this. Boom. Great. This is f prime right here times g. Any questions on that? Then she did plus, and now she has to do g prime f. Now, the way Elise did it, she did it backwards. She did f times g prime, but that's okay because it's multiplication. What I'm going to do is I'm going to erase it and go through it in the same way that I would use this formula. So when Elise did the derivative of g, this step right here, she's doing derivative of this, she realizes that that's composition. that little piece, sine of 10x, is composition. That's just like we did sine of 4x, right? So she had to apply the chain rule to this piece. Am I describing your thoughts, Elise?
Yes, you are.
Okay, so Elise then said, okay, well, I have an outer and an inner, so when I take the derivative of this, I go derivative of the outer, which is cosine, and inside of that, I don't change it, it's 10x. Then multiply that times the derivative of the inside, which is 10, and that takes care of the chain rule. But what still remains? What have we still not put here?
F.
The F from the product rule, right? From the product rule, we still have that F to throw in here, so we got to throw the x cubed at the end. And then all Elise did, she just rearranged it, which is probably because you've seen the formula in a different way, which is fine. If I were writing this answer, here's how I would write it. I would bring the 10 and the x cubed out to the front. Like that. That's the way I would do it. But there we go. So this is your first example of a problem where you have a product rule, and within the product rule, you had to do a chain rule. Do you all see that? Any questions on that? Let's do another one. Sorry, I'm thinking. Now we're starting to get to some more complicated sort of things here. Laura, are you there?
Yeah, I'm here.
Okay. So Laura, just tell me what you're seeing here.
Right now I'm wondering if I can rewrite it to get rid of the square root. I'm not too sure how.
Okay. When you say get rid of the square root, what do you mean get rid of it? Like you just want it to go away, or?
Like if it was like square root of x by itself, you could do like x to the 1/2.
Okay, yeah, I see what you're saying. Yeah, you could do that, but it would have to be everything to the 1/2. So it would have to be x sine x, all of it to the 1/2. You could do that. That'd be fun. Do you want me to do that? That's not illegal. I can do that.
Sure.
Okay. Now, do you see, okay, so if you, now that you've done it, do you see anything else?
Well, I see that there's a product rule with the x times sine x.
Okay, good. There's a product in here. Everyone see that there's a product? Good. Now, the product, though, lives inside this thing, right? Like if we look back here, this product lives inside the square root, doesn't it? So this thing lives kind of inside this parenthesis that's raised to the 1/2. So Laura, do you see an onion that has layers here? Do you see like an inner layer and an outer layer?
Yeah, I think the x times sine x would be the inside.
Okay, I agree. This is kind of like our inner layer. And then what would be the outer function then?
It would be the square root.
Yeah, the square root or the 1/2 power. This right here or this here would be our outer. Yeah? Okay, so let's stick with this, Laura. I agree with you. Let's now try and find the derivative. So according to the formula, if we have f and inside of it we have some function g, and we want to know the derivative, right, of this thing, if y is equal to this, then the derivative of this should be the outer one's derivative with g plugged in. Don't touch g. And then you can multiply times the derivative of g. So what's the outer one for you, Laura?
The outer one is the square root.
The square root. Okay. So do you know what the derivative of the square root of something is?
I would do 1/2 times the.
Okay, so good. So you're doing the power rule.
Yeah.
Is everyone clear on that? What Laura's saying is the outer function is this raising to a 1/2 power. And Laura's saying to take the derivative of something to the 1/2 power, you bring the 1/2 out. And then what do you do?
So then I would multiply that by the inner function.
So you go inside function, and I'm not touching that, right? X sine X. And what power am I going to raise that to?
To the negative 1/2.
Negative 1/2. Perfect. Okay, that is perfect. Does everyone see what Laura's done? Looked at the outer function as being the 1/2, took the derivative of that, which means bring the 1/2 out front. Inside of it, do not change it. It's the G, right? Untouched, and then raise that to the negative 1/2. Laura, are you done?
No, then you have to multiply that by the derivative of the inner function
Okay, and how are you going to handle the derivative of the inner function?
with the product rule.
Perfect. So now Laura's saying, now I can go and look at that as a product and do the product rule right here. And I suggest you just get a big parentheses ready, because whatever the product rule spits out is the derivative of this thing. You want to try and get that product rule?
Sure.
You're doing good. Okay, so what's the derivative of this with the product rule?
So it's just going to be 1 times sine x, or just sine x, plus x cosine x.
X, I'm going to write cosine X times X, and that's because that's the derivative of this one, boom, times that one, boom. And then you move the X out in front here, and that's fine. All right, this is it. Perfect. Good. Who has questions on that?
I do.
Go ahead. What do you have?
Would we still be able to do the chain rule on like the sine x but and the cosine x, or am I just or am
Say
I wrong?
again. I'm not sure I understand your question.
You know what? I think I answered it myself. Now that I
Sure.
really think. Yeah.
Okay, yeah. This X and this sine X are being multiplied, right? And that's why we do the product rule when we take the derivative of the inside. All right, I'm going to give you one to work on.
Hey, Professor.
Yes.
So I kind of didn't get that. Why did we put this? I mean, why there is a power of -1/2?
Okay, so right now, Dupree, if I asked you to take the derivative of X to the 1/2, right? I say, hey, come take derivative of this. What would you do?
I mean, bring that
Bring the half out in front, right?
Right.
And then wouldn't you subtract 1 from this power?
Right.
And if you take 1/2, right? Subtract 1, you get negative 1/2.
Right. Okay. Yeah. Got it.
That's where
makes
that
sense.
negative 1/2 is coming from.
Thank you.
Good. No, these are good questions, right? Because these are the types of things that if you're not making that connection, it makes it very hard to move on to like the more challenging things. All right, let's do another. Yes, Danielle.
So I just had a quick question. So if you were to try and put everything like the 1/2 sine x or whatever, like you can't write it as a fraction because it would just make everything look crazy, or is that not something that you're able to do?
So here's, if I were to try and simplify this, here's what I would do. I'd leave the 1/2 here. This right here is all being raised to a negative power, right? So I could drop it down. So it'd become 1 over that to a positive power.
Right.
And then those two out here would just become sine X plus X cosine X, right? You okay with that step?
Yes.
Then what I would do is I would slide this up to the numerator, because
Right.
this is really like a fraction over 1.
Over 1.
So I just put that up on top. And on the bottom, I have a 2 down here.
Uh-huh.
And then this right here really means the square root
Right.
of X sine X. And that would be a very nice cleaned up version of the answer.
Yes. Okay. I just wanted to be sure that that would be, that I'm thinking of that correctly.
Yep.
Okay, cool.
So the way that I've always taught this course is I want us to be able to get the raw derivative. The algebra to simplify it is actually sometimes harder for students. but I want to do like one thing at a time. I like to make sure we can all get the derivative first, and then if the algebra becomes an issue later, it becomes an issue later. But when you try and do them both at the same time, students usually have a problem with trying to learn the chain rule, and then they get this algebra that they just start to struggle with, and it just makes it, I think, a little demoralizing for students. So
Okay.
let's just focus on the derivative, right? What's that?
Oh, and my apologies. It's just that
Oh, don't
in
apologize.
my head, you know, like I'm getting confused because my head's thinking like I guess ahead, and I'm like I
Ahead
have
of where we're
questions
going with
about
this.
it. Yeah. So then I
Yeah.
have questions about it, like, oh, do I do this or not? So
Yeah.
thank you for answering my questions, and I'll do my
No,
best.
keep asking. I'm just pointing out to you why, I'm pointing out to the class why I didn't go all this way. I didn't go all this way because we'll have time for that. But if you can't get this first line, there's no sense in me showing you all the algebra, right?
Okay.
There's just no sense in it.
Okay.
Okay, here's another one. All right, you try. I'll give you a few minutes on this one. I think what I'm going to do is I'm going to write the answer down, and then you can kind of look up and see if you're getting the same thing. So I launched a poll to see whether or not you got that answer or not. If you didn't, just say no. It's okay. I just want to kind of get a feel for where y'all are. All right, so I have 17 responding, or 18 have responded. 17 of you said that you got the answer, which means I guess it makes sense. And I have one person who said they had trouble, I guess. I would like to ask that person to tell me what the issue is so I can help.
I put no. I got the second half correct, but the first half I just didn't. The exponent got me messed up pretty much.
Okay, so you understand this part right here.
Yeah, I have that
Quotient
like,
rule.
correct.
So the outer function is actually the seventh power, right? That's the outer function.
Yeah.
And then the inner function is all of this, right?
Mm.
So if you start with the outer function, the question is, what is the derivative of something raised to the seventh power, right? So you bring the 7 out front, right? That's this. And then you take whatever the inside was, leave it alone. That's your g of x. And then now you subtract 1 from the power, and that's where you get to 6.
This is kind of confusing me a little bit, just because whenever we take a derivative of just 7, like isn't it supposed to be 7x, then it's gonna be only 7 derivative?
Well,
So
you're
why-
not taking the derivative of just 7. You're taking the derivative of something to the 7th power, right?
Oh, okay, okay.
Right? It's
Yeah.
not the derivative of 7, it's something to the 7th power.
Right.
And so the
Got it.
derivative of something to the 7th power should be 7, and then that's something to the 6th power.
Got it. That makes more sense. That's
Good.
what was kind of messing me up.
You know, when I'm teaching this in a classroom like face to face, what I do is I actually put this problem up on the board. And then what I'll tell I'll actually like pick up like an eraser or something laying around, a textbook, and I'll actually put the textbook completely on top of this, and I'll cover it. And then I'll ask Dilpreet, I'll say, Dilpreet, what is the derivative of a black box raised to the 7th power? And you
And
will tell
7
me
up front, and it's whatever.
7, and then you'll tell me it's the black box, right?
Yeah.
Raised to the
6th
power. And then I say, okay, good, Dilpreet. Now chain rule says times. Now you can uncover the box. And now Dilpreet, tell me what the derivative of this is. And then that would be this part, right?
Right.
That make kind of sense?
Yes, sir. It does.
Okay,
Thank
good. All right, we ready for more? There's no such thing as seeing too many examples of chain rule. There's no such thing. All right, so how about this one? Now, I'm going to let you work this one, but I want to just remind you that this 4th power right there, what it really means when you have a number right there above the trig function, what this really means is that we have secant of x to the 6th minus x to the -1, all of that to the 4th power. You know what? Let me work through this one. So first you have to understand what that means, okay? That this 4th power means that you're taking the secant and the stuff inside the secant and you're raising it all to the 4th. So is that all right with everyone? Yes?
Yes, it is.
Okay, now what you have to see here, and the reason I'm working this one out is because I realized after I wrote it down, we haven't talked about this. We actually have 3 layers to this onion. There's not 2 layers, there's 3. Sorry, there's not 2 layers, there's 3. We have an inner function, right? Then we have like a middle function, and then we have like an outer function. And so how do we do this, right? I haven't shown you how to do this. So what do you think we do? Does anyone have an idea what we would do, where we would start?
I would
The
put
product.
oh, I'm sorry.
Go ahead.
I would move the 4 to the front, and then I would put whatever's inside. So secant times x to the 6 minus -1 in parentheses. And then from there, do it again by getting the derivative of what's in there, and then so on and so forth of like
Okay.
off,
Yeah,
right?
so we have this idea of this like inner layer, middle layer, outer layer. We always start with the outer layer, and then I think I'll go back to what I showed Dilpreet earlier. If you just look at everything on the inside as being a black box, then the first step of the derivative of the chain rule would be to bring the 4 out front, and then take that black box and raise it to the 3rd power. That's the first step, and that would be the outer layer's derivative. Any questions on that? Okay, now I need to unhide the black box because there. And so I'm going to put that in here. Okay, everyone good up to that point? Any questions at all on that? We're not done. Chain rule now says times. Now, haven't we finished the outer layer? Isn't that 4 gone now?
Uh-huh.
Yeah. So now just treat this like it's a new problem. You have an inner layer and an outer layer. And just do the same thing. So we start with the outer layer, which is secant, right? Now, Claire, are you here? I don't see Claire. Natalie, you here?
Yes, sir.
Okay, so Natalie, you following so far?
Yes, sir.
Okay, so we've taken care of the 4th power. We're now in the middle layer of the onion, which is which function? Which is the middle one?
That secant x.
Where'd you go?
Yeah, I think you cut out, Natalie. I didn't hear you if you said something.
Oh, okay.
I'm trying. Can you hear me now?
Oh, you know what? I think I have 2 Natalies. That's why. I'm sorry. I'm Natalie Lozano. I'm sorry, Natalie. I already called on the other Natalie, didn't I?
No, that's the same person. I can hear you better on my phone versus.
Oh, you're
like,
the same person. Okay, sorry.
Yeah.
Oops,
Yeah.
okay. I'm like, okay, so what's the middle function, the middle layer?
The secant.
Yeah, the secant, right?
Yeah.
And you need to take derivative of secant. So Natalie, what is the derivative of secant?
It would be secant x times tangent x.
Good. Okay, so I'm going to write this down on the side, everyone, just because we need to know this. The derivative of secant x is secant x tangent x, right? According to the formula sheet, what we've learned in this class already, that's derivative of secant x. Natalie, we don't have secant x, right? We have secant of secant of a blue box, right? So Natalie, what's the derivative of secant of a blue box?
Would it be like secant of that same blue box times tangent of that blue box?
Yes, exactly. Okay, now I need to know what the blue box was, but I covered it up, right? So I need to uncover it. So Natalie, what goes in that blue box here? Or what goes in that little box I left the space for?
X to the 6th minus x to the -1st power.
Yep. And then same thing with the tangent, right?
Yes.
All right, now is a good time for questions. We did the outer layer, 4 came out, everything to the 3rd power. That's, I think most of you are okay with that. Then Natalie said the next layer of the onion was the secant, and anytime you take derivative of secant of something, you get secant of that something times tangent of that something. And the thing that was in the secant here was this. So when we took the derivative, it had to be secant of that, tangent of that. The biggest mistake I see people make here is they actually write secant x, tangent x. That's incorrect because of chain rule. So is that clear to everyone? Okay, we are done with secant, and now we move to the final layer. So we chain rule times, and now the final part here. Carla, are you there? Carla. All right, Ryan?
Yes, I'm here.
Oh, Carla, okay. So you get that last part.
Yes.
What's the derivative of that last piece?
So it's 6x to the 5th.
Mm-hmm.
And since it's negative, it's x to the negative 1, that would be plus x to the negative 2.
Perfect. Okay, there we go. There's the derivative.
Should you put a parentheses around that entire second half?
Which one? This?
Just from secant x to the 6th to the very end.
Yeah, so this is where this is very common in a calculus class for students to be like so paranoid about parentheses that they start just throwing parentheses everywhere to try and be safe. My recommendation would be to look at the operations you have. All of this, right, is one what we call factor. You plug in an x, that's going to give you a number. This is multiplication, right? Right there, that's another number. And then you have multiplication again, you have another number right there. All those things are being multiplied together. So if you put parentheses around this, it doesn't change anything because it's all multiplication the whole way. So it's not necessary. You would need parentheses if, let's say, this was a plus. If that was a plus here, then you would have to throw the whole thing in parentheses. But because it's not a plus, you don't need it. Does that answer your question, Cody? Okay. How about this one? Y equals sine of sine of sine of sine of x. What's the derivative?
It's gonna be a pain in the ass. Hold on.
Let me give you all a minute or two to see if you can figure it out on your own, and then we'll start talking about it. All right. I think we're there. Claire, you asked me to call on you next.
Yeah.
So Claire, do you see that this is composition and not multiplication?
is because it's inside, right?
Right, it's like with these parentheses, you have sine of x, but that lives inside of this sine of x, or this sign, which all of that lives inside of this sign, which all of that lives inside of that sign, right? So nowhere here do we have multiplication.
No.
So this is all composition. So how many layers are there to this onion?
Um, 3.
We have our inner function here, right? This is our inner. This is the furthest function in. And then we have another layer here, right? Another layer here and another layer here. So this would be our outermost one. So there's 1, 2, 3, 4 layers to this onion. Does that make sense, Claire?
Yes.
Okay, whenever we use the chain rule, we always start with the outer layer, the outermost layer, and we start by taking its derivative. So Claire, what's the derivative of this?
Cosine
Cosine. Now what's going to go inside of that cosine?
would be x, or would it be sine?
Will the whole thing go in there?
Yeah,
It
the
would-
sine
It
times
would
sine
be
times sine.
everything that was inside of it. Everything that was inside of this sine goes inside of this cosine.
Okay.
Okay? So I'm going to write here cosine of sine of sine of sine of x. Now I need to have the same number of parentheses here. 1, 2, 3 parentheses there, 4. So I need 4 parentheses there.
Well, that's just one layer, and then you would
That's
have.
just one layer. All right, Claire? So now we've done this layer, right? Now let's move on to the next layer. The next layer is this one, Claire. What's derivative of sine of something, Claire?
Cosine,
Cosine. Okay, and what's going to go inside of that?
sine, sine.
Sine of x, right? So these two sines are going to go inside? The number of parentheses facing this way have to be equal to the number of parentheses facing this way. So I have 1, 2, 3 faced one direction. So 1, 2, 3 there.
Oh, I see.
Ready to keep going?
Sure.
We're done with that one now, right? Next layer in. Derivative of sine of something, Claire?
Cosine.
Cosine. So now I'm going to have cosine. And what goes inside of that cosine?
You'd have sine and then x.
Yeah, just sine of x.
Then that'll be 2, and then
Now we've done that layer. And we've made our way finally to the innermost layer, Claire. And what is the derivative of the innermost layer?
cosine.
Cosine of x. There it is. There's our derivative. So the derivative of sine of sine of sine of sine of x is equal to cosine of sine of sine of sine of x times cosine of sine of x times cosine of sine of x times cosine of x. And there really is no there's no limit to how many layers to the onion you can have. Now I'm not going to give you crazy ones that are going to be like 30 layers, but just goes to show you that the general chain rule, like the way the chain rule is presented, there's just 2 layers. But in reality, you can have multiple layers. All right, here we go. Another one.
Is it okay if I like numbered them, like the outer, like 1, 2, 3, 4, like to mark out how many layers I have going on?
Do you feel good doing it that way?
To me, yeah, just because I'm counting like, how many layers I do have of the function. I'm like, okay, there's the 1, 2, 3, and then there's 4. And then from there, I would like, okay, I'm done with 1. Now I'm going to go to 2, the second outer layer. Okay, mark that one off. Go to 3, mark that one off. You know what I mean? Is that's
Fine.
chill? Okay.
If it makes you happy and you're getting it right, I don't care. All right. Ryan, are you there, Ryan?
You said Ryan, right?
Ryan, R-Y-A-N. Sorry, Ryan, no? How about
sir,
Adair?
Is it okay if you just call me by my last name so we don't confuse each other?
If I remember.
All right, sweet.
I will try. You're usually participating most of the time anyway, so this is really just to mark people down.
Okay.
Okay, Adair?
Hi, are you able to hear me?
I can.
Okay, because I lost connection for like the last 30 minutes, so I've been pretty lost.
Okay, yeah, let me come back to you then. I'll come back, Adair.
I have a
Okay,
question.
thank you.
Who has a question?
Me.
Oh, go ahead.
So if I was to do the outer layer, like, well, actually, okay, the square root, can I rewrite that and put everything under under a denominator? Like, if I was like the 1 plus x squared, if I made that into like 1/2, would I end up putting like the 1 at the top and then the 2 in front of it, or no?
So you could rewrite this like this. You could rewrite this as sine, and then you could replace the square root. So we have sine, right? And what's inside of the sine? What's inside of the sine? Let me write it this way first, so you understand what this really means. Okay, so this written the way it is, it's sine, and inside the sine is the square root, and inside the square root is the 1 plus x squared. So it's sine, inside sine is the square root, inside the square root is this. You could rewrite that this way. That you could do. But the 1/2 would not be on the outside here. It would be just acting on this. So this would be incorrect. It's not that. For it to be this, it would have had to have the square root like that and no square root there. That makes sense? All right, so let's see. Vivian, are you there, Vivian?
She's not here. She went to a doctor's appointment.
Oh yeah, that's right. Someone
I think
sent
I
me
have the
some-
answer.
Who said that? What?
Me, Cody.
Oh, Cody, you want to go for this one?
Yes.
All right, go for it, Cody.
It would be cosine 2 parentheses 1 plus x squared parentheses close parentheses 1/2 power 1/2 close parentheses times 1/2 parentheses 1 plus x squared close parentheses negative 1/2 times parentheses 1 plus 2x close parentheses.
Almost perfect. Almost perfect. You said 1 plus 2x. Where'd you get the 1 from?
Oh, I forgot I wasn't supposed to put that in there.
You did the derivative of 1 plus x squared, right?
Yeah, I just accidentally left the 1 in there.
Yeah, okay, so you just have 2x, right?
Yes.
And you wouldn't need parentheses in that case because it's just a single term.
Mhm.
Perfect, that's great. Awesome.
I have a question.
Yes.
So the way I did it, I in the first set with the cosine one, yeah, that I left the square root as a square root and I changed in the next step. Is that okay, or should I keep it like the same?
Nope, it doesn't matter. It doesn't matter. Okay. Good. All right. Does anyone need any clarification on this? Because Cody just knocked it out, had it, got the answer. Started out with sine, right? Derivative of sine of all this would be cosine of all that. And then Cody moved on to the next inside piece, which was something to the 1/2. So he brought the 1/2 out, subtracted 1, left everything on the inside alone. And then once he was done with the 1/2, he moved to the final inside layer and took derivative of that and got 2x. Multiplied all those together. Isn't this fun?
Yeah.
There we go.
Yeah.
Hmm. I'm giving you a moment to do this. We only have 10 minutes left. If somebody who I have not called on or has not volunteered today gets it, please let me know. Okay. Gabriel, yay or nay? I see Gabriel's here. Going once. Going twice. No? All right. How about Daniela? Silva,
Yes, I'm here.
are you making progress with this at all?
That much.
What do you see here?
Is that a multiplication between the x and the sign?
Good, good. So you've got to treat it like a product rule, don't you?
Yeah.
Okay, so let's just start working out the product rule. So you start off, f prime times g plus g prime times f, right?
Yeah.
Okay, so f prime would be?
1.
Okay, and then g, we don't touch it, right?
Yeah.
Okay, then plus. Now the hard part. You got to figure out what g prime is. See, that means you got to figure out the derivative of this. And do you see composition there?
Yeah.
Okay, so how many layers do you have here?
Just 1.
Yep, you've got an outside layer and inside, right? So start with the outside.
Is cosine
Cosine, and what goes inside the cosine?
the 1 over x?
Okay, good. And now times, now Daniela, you have to take derivative of that, right?
Yeah.
So how do you take derivative of 1 over x? How would you do that?
For that one, can I rewrite as x minus
-1?
Yeah.
Perfect. That's the way I would do it. Rewrite that as x to the -1. And now just use your power rule, right?
Yeah.
So go ahead and give that to me. Derivative of that would be?
-1.
-1 x to the?
0.
You're going to subtract 1 from
Oh yeah,
negative.
it's -2. Sorry.
-2. Okay, you're almost there. That's it. You've taken the derivative of g now, right? Outer layer, boom, here, times derivative of the inner layer here. Got it. And now all you're missing is from the product rule, the f, right?
Yeah.
F here is x. There we go. we're done. That was the raw derivative, but if I were to clean this up, here's what it would look like. Because this right here really means 1 over x squared. And when you put that together with this x, one of the x's would cancel. And so that's why you just have 1 over x out here. And then the negative comes out here. Does anyone have any questions on that?
Yes. So the reason why we didn't count the 1 over x as attached to sine is because it has the parentheses there, implying that it's multiplied and it's not sine.
You mean the cosine x or the sine x? You said sine.
Yeah, so like at the beginning, x times sine 1 over x, you know how like usually if it says sine x, that x is attached to the sine function. So the 1 over x isn't attached to the sine function. It's just, it's its own thing.
No, it's inside the sine function. It's just like when you write sine of x, that x is inside the sine function, right?
Okay.
Here, the 1 over x is inside of it, which is why we had to do chain rule when we took the derivative of it.
Okay, then. Because I thought that earlier you were saying that it was sine over 1x was sine times 1 over x, like they were two separate things. But that's not what we're doing. I just wanted to be sure.
Okay.
How would what would you suggest to not get lost in problems like this? Because like I had everything done, but in the product rule I forgot the final f because you know there was so much going on. I forgot to add the times x. So
My recommendation to not get lost on this is to do every single homework problem that I assign to you and make sure you check it with my answers and my solution videos. Make sure that you're getting the same thing I'm getting. And then you will make less mistakes the more practice you make, or the more practice you have.
Okay, yeah.
What you can't do, and I'm telling you this from the bottom of my heart, what you can't do is sit here today and say, I get it. And then just trust that when you're presented with a problem on a test that you're going to be able to figure it out, because you'll make those mistakes. You'll overlook a product. You'll forget that you have that F on the end. So it's just really just practice. And I think when you look at the problems, you'll see that they're all just, each problem is unique. Like I could show you 1,000 problems today and then come back and show you 100 different ones the next day. And there's just no real limit now as to how bad or how weird these things can get. Here's something else. We only have 4 minutes. Here's something else we haven't even talked about. Austin, I hope that was a good enough answer for you. It's really practice. So what if we take something like this? And I ask you to find y double prime.
You take the
That's
derivative.
the second derivative, not the first derivative. I want the second derivative. Well, we've talked about derivatives and how if you want the second derivative, you just first have to take the derivative. And then whatever that answer is, you have to take derivative of that, right? So let me work through this. If I take derivative of this, this is chain rule. I have an outer function of sine and inner function of x squared. So I start with the outer function, derivative of that's cosine, and I put the inner function, I don't touch it. Then I multiply that times the derivative of the inside function, which is 2x. And maybe I clean that up. I put the 2x in front, cosine of x squared. Okay, that's y prime. Now, y double prime, I have to take derivative of this, right? And so I have to recognize now that I have a product. So I've got to do a product rule. So the derivative of this would be the derivative of the first one, which is 2, times the second one, don't touch the second one, plus now the derivative of this. But that's chain rule, right? Because I have cosine of x squared. So derivative of cosine of something is negative sine. I'm going to put a negative here, negative sine, but inside of it goes, not x squared. Then times, now I can do derivative of the x squared, which is 2x. And then Austin, this is where I would need to remember, I have to throw the f on there, the first function f, right? So this was my f, this was my g. This is f prime right there times g, plus all of that is g prime and then times f. Okay. All right. So your homework assignment for this is chain rule 2.5 in the book. It's actually page 120. It's all these problems. And I expect that you will do at least through the last problem, number 46. Let's see, 46 is, I'd say the last three are going to be a little bit tough, and we may need to come back and talk about those. But I really do expect that everyone's going to get through at least these right here. And notice that in that assignment, I really didn't assign every single problem. So my recommendation to you would be to do all those, and then if you need more practice, just do the ones I didn't assign. All right. Now we meet again on Thursday. Man, I don't like babysitting. This is college, so I don't like babysitting people. But this is such an important homework section right now that if you were in a face-to-face class, I would ask you to come in next class and have your homework, have this section's homework ready to show to me. And I'd walk around the classroom and I'd look at everybody's homework just to see that you made the honest effort to do this, because that's the only way you're going to get good. It's the only way you're going to recognize your weaknesses. So let's say on Thursday, I may ask you to just like show me your work, like just like hold it up to your camera, just so you know I can see that you've tried these. And if you don't get through all of them, you don't get through all of them, but you need to at least attempt 80% of them. All right, and come with questions. All right, come with questions if you have things you're not sure of. And just remember, I have my homework solution videos. Right, you can always go to the YouTube channel, my YouTube channel, and you can watch me work these problems out on the board. But yeah, that's all I've got. We got to go. Right, it's 2:41. So I'll hang out for a minute if anyone has any questions. If not, have a good rest of your day, and I will see you on Thursday. Do your homework.
I had my little question, which was, is it cool, like when I'm done doing my homework, I scan it just like how we did the test, and then I send it to you so that way you can